Hello guys, and today I want to make something. I don't know what to make, really. I mean, we could play around with a lot of stuff. There's a lot of stuff out there. Like there's a lot of stuff out there I could mess around with, but I don't really know what to make today. So, I'm just gonna go ahead and get everything set up real quick, and then we can figure out what we're gonna do from there. Because I don't really know. We could like refine a previous project or some shit, or like revisit Fish AI. That was a dumb idea. What a dumb idea that was. I mean, or what I kind of want to do today, now that I think about it, is I want to make something that runs in the terminal. I want to make like a terminal system, and I think I can do that now because I learned a bit of stuff from when I was writing code for an OS. So I think I can actually potentially pull off something new with that. Let me just open up this. No, please, please keep it normal sized. There. Alright, yeah. So that's what I want to do today. I want to make some fucking terminal stuff. Create create a folder, I guess. Yeah, we'll call it terminal GUI. Terminal GUI. Yes. Perfect. Create documents, empty file. Terminal render.d. So yeah, we're gonna create this today. Because you know, like, everything that runs in the terminal is fucking crazy. So like, when you have stuff in the... Fuck you, NVIDIA! When you have stuff that runs in the terminal, it's really interesting. What are we gonna... We're gonna use, like, do it work in any kind of, like, advanced... Nah, let's hold off on... Well, I would like to work with, like, LD and stuff, but... Anyway, so the terminal is made up of... like, rows and columns. No, it isn't. Is it really? Could it be? How do we determine where something's gonna go in the terminal? That's, like, the real question. Void. I guess we'll just start off by making a void and then going from there. We'll call this void. I don't even know. Void render. And then, yeah, that's a good name actually. I think that will work. So that's just gonna basically place something in the terminal, and then we're also probably gonna need a... Well, I did learn one thing, and that's that you can make global things by defining them as, like, what is it called? It's like a G thing, fucking... Can't remember what it is, but you can technically define them as global. But anyway, let's say we have a grid, right? Like, whole terminal, we just render into it as a grid or something? I don't know. How does things like htop even work, bro? Like, how do you even do that? I mean, I guess they have like bars for those, but then that's probably also advanced. I guess I'm gonna create my own library that does a lot of that stuff. This will be a cool thing to make. I just need to come up with a position system. So anyway, struct. I'm just gonna make a struct for this, although there is ways to make a global variable. Which you define like, how would you do that actually? Open G shared. So you could do shared, I'm guessing. Shared int x and then int y. Now the difference is that, like, you know, with with terminals, you don't have like memory that is like for the position, do you? Like whereas in a OS, in that fucking, after you've gotten into your kernel, you have like, you can literally just do that where you have this thing, vidmem, x position, y position. You can do all of that inside of in that. So that just leaves me with like, what do I do? How do I define where the item's gonna go? Or where the thing is gonna go? So there we go. Y pose and X pose. I'm gonna define them as equaling 0, both of them. Cool. That's my first step. How does terminal see if we can find any forums or anything. I guess we could just do math. Be like, all right, I want the, let's say I have X pose and a Y position, right? So each of these objects, right, we could be like, or we could have one that's like a render a line, render this. Instead of thinking of it like, we're thinking of it too differently. Like, it's not gonna have that. I don't even need to search up what I need to do, actually. So you would have a car, right? So let's say you have a car, and that's the one you want to render. Car character. I'm very creative, guys, if you couldn't tell. And then you have an int for X position, X pose, and Y pose. I think you can define it like that? No. How did I define it in that one? I was able to define multiple with fucking... no, that only works if you declare it beforehand. So anyway, we declare X pose and Y pose here. So the car is going to be... Also, we're going to import globally. So let's do a global import. And also give a module name. Import standard.standard.dio. Although I might not use that. We might also import concurrency to make it more efficient. That's so dumb. But yeah, I might do that if I feel like I want to render even better. So render a line. Well, I think you could just do it in one right line. You just append it to itself a bunch of times. Although that might not be the fastest way of doing it. You could also use a GL thing to do it. GL acceleration. Do we want open GL acceleration? Oh, hell, let's use Vulkan to make some... Well, with GL, we just make a buffer. I think we could then be like, buffer, do this, and then it returns what we need, and then it does all the stuff. Boom. GPU acceleration for it would be insane. But anyway, for now, I think I'm going to start off with the basics, because that's a good starting point. Module is going to be called terminal render. But that doesn't work because that's not a cool name. That's not a cool name. Your name is uncool. Terminal.render. There we go. Now I have to rename it. Congratulations, me. I'm bad at naming things. Terminal.render.d. Alright, so now I got my car character. I want to make that easier, so I'm going to just put CHR. So there we go. Now, what it's going to do is it's going to take X pose and Y pose, and we're going to make a line from... Actually, we could do points, but in this case, we're going to do... Oh, well, that would make a square. Let's do points instead. point A. Well, actually, I think most people do this nowadays. And then point B. So that's my render. Alright, so now point. What we're going to do is we're going to take point A and point B. We're going to do math. How are we going to do the math, though? So if point A is 1, that's where it's going to start at. So we need like a case, kind of, almost. No. But these would be exposit. Well, if you want a line between 2 points, you'll need to do fucking quantum trigonometry. Render. Line. Render horizon. Horizontal. You know, like across. We'll just start there. Right, that would make it easy. So point A. If it's not at point A, then... Well, you could do one that just loops through it, but that'd be terrible. We need a for loop. For. Go with for, because this will make it simple enough. For int I equals 0 semicolon until I equals the from here to here. So if point A is like what, 32, we'll just generate nothing until 32, right? So for int I until int no. What do I do? For until I equals point underscore A do that, and then we're gonna create a line. So why is this wrong? Why don't you like that? Why are you? Oh wait, because I forgot one of the components of this for loop is that you need to have an I++ at the end, which I've started doing it like this because it's more correct. Even though you can do ++I and it doesn't really make a difference. So until I equals point A, do that. Now once I equals point A, it's gonna create it's gonna have a string initialized at the beginning. So let's go ahead and tab string render. So it's gonna return render, pretty much. That's really easy. I don't even need to import standard DIO up here. Get rid of that, because you know what I can do is in my main function I can import it. I won't even need it globally. That's actually really good. I like that. Alright, so then I can just do append to string. No, append to render the character literal for space. Which is that. It's fucking amazing. It looks so dumb, but it will work. And then, if we have it equal to that until it gets to point B, then don't do anything. I'm sure there's actually a way of doing this, and it's called like formatted print, but this is cool though, because eventually I plan to make entire squares, triangles, and different shapes. It will be a fun project. 0, semicolon. And it's also an easy one, so I can get back to it, since all weekend we just installed Arch Linux every day. And I didn't even do any... oh, and that says if it equals that. And then... once it equals that, it will do this. So, does not equal point underscore b. And now every time it exits this, it will reset. So we don't want that. Instead, we would want to go straight to the next loop, or have int I be outside of this, which would be even better. So you would do it like this, where you don't declare it at the start, and then you can do int I, and then on exit you could have a I guess you could have a function that just render, and then this equals chr. So now we can test it out. I++, and then that creates our function render horizontal. Pretty cool. Alright, so void main. Time to make a function to test with for now, because I'm getting ready to do that. What is it? Render horizontal. And I want to put, let's say I want the equals, like the literal for equals. I want to do that, and I want to do it across the screen from 4, and I want to go to 16. Like programmer numbers, bro. That got that programmer brain on. Cool. Now that creates that, so now I can do DMD. Oh, I'm not in the correct directory? Wow, I love this. Alright, let's go ahead and DMD terminal render.d /. Oh, probably should remove the .render part. Rename. Get rid of this. Why is it terminal.render? Bro. Rename it to that. /terminal. Sent a gift. Hello, thank you. Sent star for 2 joules. This is cool. Whoa. Terminal. Am I dumb? I think I'm pretty dumb. Let me rename this. I think that's part of the issue. First of all, wait, am I even in the correct directory? That should be a question I need to ask myself, knowing my luck. Rename that. Oh, terminal render.o? What? Who put that there? Oh god. Close file. I hope I didn't break it. What are you doing? Practicing? Yeah, I want to make like some kind of library that renders lines and things in the terminal. I want to make my own version of HTOP for a project. I think that'd be a great idea. I didn't really know what I was going to do at first, so I was like, yeah, I don't know what to do today. It doesn't do anything. CD desk. Oh, why am I trying to do it into root? Slash, and then do D tools, and then slash. Dot slash. It doesn't do anything? Does it? How does it do anything? Oh wait, because this doesn't do. No, I'm really dumb. So I want to return string, create this into a string function, and then return string instead, and then return render. Then all I have to do is put this in a write line. But that needs me to call standard DIO. Standard IO. Import IO. Wait, am I getting confused? Yeah, I'm getting confused again. Do that. And then I need to just import write ln. You can also do like printf and stuff too. I think those are more compatibility stuff, but or writef. All right, now that starts at 4 and goes the length I wanted. That's pretty cool. That's actually pretty efficient too. If I go for like 5 and I go, let's say 60. Let's go with 23. Let's do that number. Very cool. You'd also make a function that allows you to do it inside of here. Although it'd be cooler if I could like resize it and it changes with the terminal, but I don't know how to do that yet. I'm not really that advanced with. I need to do more research in the fucking terminal stuff. Terminal stuff is what I would need to research. I want to make a vertical line. That means I'll have to print a new line character after each line, probably. So probably the same code, we just do it vertically. So instead, it just renders a new line. And then... So... Now that we figured out how to put it at a position, making a function that's going to be able to place a vertical line like right here and go down would be incredible. But it's not going to be hard to do, I don't think. So you would have to alternate between the character you want and so on. Also, these points, well, I think we could change these to structs. Let's actually try that out with the vertical version. Or with the regular version. Or actually, instead you could just have one function that handles both. We just need a struct. So, struct, what we'll do is call this a point, and instead it will be referenced as 2 coordinates, so it will be like so a point consists of, and then you would also need a, you wouldn't need a constructor, you could have one, but point struct, and what you do is you go x coord, so int x, yeah, x coord, amazing, and then int y coord, and then you do a function that, you could set a function that makes those. also need to fix that. Alright, so that's pretty much everything I need. It just looks weird for some reason, with those being like that. Although, it'd be better if it was just an array. And we just called it coords. And it's gonna hold 4. Yeah, like OpenGL almost. Like have it have multiple. So we'll have 4 coords. That's gonna place our line instead of this. So that will be a different thing. And then instead of doing a line, we need to render it as a square. Let's say that this part of the terminal is 0. So wherever the line you're rendering from is 0, then yes, that will be how I do it. So we have 4 coords. We need to probably create a function to declare points. You could just... No, that's only if you have like a global thing, I think. Anyway, we're gonna go down here, and we're gonna declare a new struct. So we're gonna auto struct, or no, auto the coords for point. No, don't do that. That's not how it's done. Point equals points. Great naming, and then you do need one of the, or equals point. I mean, I guess I could just do it as like a coord instead of using a struct. I can just do array, but that's lame. That's kind of lame. Why would I ever want to do anything besides have a struct there? I also don't remember exactly if you can initialize this in this statement here. I think you have to create it, and then you need a function that does that. So, I mean, I'll make a function point, which is going to return a point, or point make. Yeah, that's the way to do it. So you do point make, and then you take those, and it just takes an int array of 4. Int 4, and then we do our coords return coords. And then how do you call these? I need to open an example of it. Where is... I think I did it in one of these. Or it was in classes, or one of those. I had done this a long time ago. I haven't done it in a very long time. Structs. Here we create these. These do a group. Oh, wait a second. So when you do this stuff, you don't even need to do that. That's just an extra step if you want to do it. Never mind. So yeah, I can do... How do I do it in here? You just do a group ID and then group users, which is pointing to group users. Cool. So that's one way of doing that. You would just do it in here, I guess. You do coords for, not 43, and then you do equals, and then create the array. Let's say we want it to start at 2 and 3, and then we want it, well, that's 2, 3, and then we want to go to the next one. So that means it needs to go down 3. I think the way it's going to render is I'm going to start by doing the vertical. So what I'm going to do is go down 3 and then go across. So I'll do the y-axis first, and then we want to do 4, let's say we want to do 5, because this will allow you to make any shape, like a rectangle or whatever. 5 is lower than that, so only the vertical should change in this case, unless we want to get into more advanced stuff. So let's try that. Let's try getting it to where I can render a basic line with this. Alright, so then... Oh, we could also even put the car in there as well. And it just takes a point. But it'd be more universal if you had just a point. Alright, so then instead, we'll still have int I on the outside because it will do a bunch of complex shit. So first thing we might want to do is create the shape in a struct. That's a bad idea. Well, we could do that if we want to parallelize it. If we want to parallelize the task and then create it in a struct, that's always an option. I don't really feel like doing that though. Such hard decisions to make. 4, and I want to do. Well, the first step. See if we start at, let's say 3. Where does that put me at? So that's 3 from the top. So I want to render at 3. That puts me 3 from the top. So I want to do that y-axis first. So it's actually going to take a point. Point. And then point. Cool. And we have a point here, and we're gonna render like this. So let's go ahead and render and then do my car. Let's do O this time. O, comma, and then point. How is this not used anywhere else? Alright, so render O and do it for points. And then the X starts at 2. That means every line needs to have 2 before it. So that means that string render will always equal 2 every time it gets into that first loop. So I guess string render should just be initialized with 2 of those. Or we need to make a copy of it, but that's not memory efficient. It would not be CPU efficient to do it where we initialize it with the... Well, I guess it would be, but like it'd take more steps. To do, I think it'd be less memory efficient if we had 2 copies of render in memory, though. Like, anyway, what we're gonna do, I think, is probably go ahead and make our for loop, and string's gonna be initialized inside the for loop every time. Actually, that'd be terrible, though. Nesting for loops like this is terrible. I don't like nested for loops, but I mean, we could just take that, and that means that there's, instead of looping it and adding that, you could just set it to equal that. How would you add 2 of those to it without looping it? Set string render to equal those. So, it's such a hard thing to do. Can I just set it to have 2 of those? Hold on. I think you can. String render equals, or append, semicolon, and then you would append the length of, that'd be in the for loop though. Or we could do a while loop. I feel like a while loop would be better. While render. Or while true. Just make an unconditional loop. Just to make it simple, since it's gonna loop through and basically create it. And it's gonna go line by line, so while true is just the rendering loop. And what we'll do is we'll be like, alright, while true. There's a way to do it though, the string delimiters, right? Or string or formatted format string d-lang. Should pull up the results we're looking for. Provide support, so we would want formats probably. Oh, right. So if you want to, yeah, that's the way to do it. Anyway, format. Do. Here are 3 apples. Wait, what is this? Does this cover the actual formats and stuff? Oh, here we go. S, the name if input range. When outputs, what the fuck am I saying? When elements of a range are characters, they are written like a string. In all other cases, the elements are enclosed by square brackets and separated. Struct, class, union, pointer. SymD vector? SymD vector? Whoa. Fun stuff. The real fun stuff. Honestly, I think it'd be cooler to make a program that reads memory and allows you to debug. That'd be pretty cool to mess around with. Please note that OX might produce unexpected results due to handling with the special value 0. So I think we'd do a delimiter of slash of some kind. Position. By default, oh, why did I put it over here? What am I doing? Anyway, so what is this? Position, right? It's also possible to position arguments with width, precision, and maybe I should just fuck around with precision. Semantics. I like semantics. Oh, these are amazing. To be formatted in a human, to be formatted as a character, sign decimal, octal image, real number, scientific notation, endianness. What else you got? Honestly, what if we try revisit those 1 programs that I made a long time ago? The encryption programs of all time. With the knowledge I have now, That's a great idea, honestly. Let's redefine what my goals are today. My goal is to redo the old programs from the past and relearn standard.concurrency. Rename encryption mk4.b. Discard. Oh wait, what? Alright. Amazing. Alright, so the first steps are creating functions and going to figure out the slicing stuff. Since that's one of the big things that was a struggle in the past, I think we just convert it into like base 64 and then split it and then... So let's learn standard base 64 and then work from there. Since that will be the first step of parsing the string that we're going to put in. So base 64 URL. Blah, 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 blah. Which one? Base 64? Alias base 64 equals base 64 imply. For description of available methods. Decode, encode. So it wants a source input range to encode and a car buffer. Oh, I know how to make one of them. But anyway, once car probably has range 1 and range 2. So what we would do would be cast it all to like U bytes. We'd cast it to like a U byte array and then shove in the U bytes and then get it out. Alright, so let's start our void main. Man, I really had no idea what I wanted to do today, so. Void main, import, IO, standard.stdio, write ln. And then we want to take a string, so we want to read f. Oh, actually, we might want that too. So, might want readf. I don't remember if readf is correct or not. It might be readln, but readf should do the same thing. Alright, so we're going to readf, and we want to put in string input equals readf, and then we do this and that. And well, actually, there's a way to format these using this anyway. Right, and then let's go ahead and write ln and do input. That's a good starting point. Alright, so let's go ahead and test it. DMD tab. God damn it! I want to do the one, but it's Oh, okay. So here we go. Here's what we're looking for: string input, callable using the types. Readf alias format. Hold on. How do I read lines again? I could do read ln, I think. Read ln and read ln. Control S. DMD. Alright, so now hello world, which prints hello world. That's cool. So the next step we need to split it using, well, no, we don't need to split it, but we could split it now and then not even worry about it until later, but we could just convert it all to base 64. So let's go ahead and split it to base 64 since that will serve the purposes. Let's go ahead and convert it to a U-byte. So we're gonna cast U-byte array from string input. Let's hope that works. In theory, you could just oh, has no effect? What do you mean has no effect? I mean, I guess you'd put the cast inside the actual one right there. That's where it's at. Alright, then that casts it out, Control S. Then, hello world. And that's what the array looks like. So that's what we want. The next step now is to take that range and encode it. Since the slice buffer contains the encoded string. Alright, so here we have encode and it has R1 and R2. Or no. Hold on, here's how you use it. Examples. So there's a U-byte and then there's a car32 buffer. Much bigger than necessary. So that means you take a U-byte and then you encode it. Or, I mean, we have an array of these. I mean, now I have numbers that I can work with. Bro, this is crazy though to me because back when I did this the first couple times, you will see my code was just 3,000 lines long to even do anything. Now I know how to turn it into different values, and then we'll do math. So instead of doing all of that extra stuff, we'll cast the input to U-bytes. Then we're going to operate upon each of the arrays. Basically, what we're going to do is make a U-byte array. And let's go ahead and put that in a... let's make this small so I don't have to worry about it. Actually, hell, we could even encase this inside of a guard. Scope guard. Honestly, could just do it as a function too, even. Void. Hell, I could take that and cast that out as a U-byte already. Bro, that is like stacking. Alright, let's go ahead and work functionally. Let's go ahead and create a, instead, we're gonna make a U-byte array straight away. So U-byte array. Bro, that's crazy. U-byte array function. And it's gonna return a cast. Cast U-byte array. And then input. I hope that works. And then we're just gonna move all of this out. Put it outside there. It gets evicted. Then reduce all that so it's cleaner. Boom. And that's gonna go there. Something's not right. Where is it at? Oh, it doesn't have a name. Okay, so the function name, we're gonna call it read. And let's just say make ubyte. Alright, awesome. So make ubyte exists. My make ubyte function doesn't really do much. All it does is call string input readline, and then boom. So then all it needs to do is this, where it's going to cast a function. Bro, how the hell does that even work? So we're gonna go ahead and do make ubyte write ln, which contains a function that reads a line. Does it work, or does it not work? Alright, I need to actually... Bro, that's the only thing wrong with this. Import standard dot write ln. Awesome. Oh, did I just... Fucking brilliant. Oh yeah, truly awesome. stdio colon write ln. Awesome sauce. Alright, so that makes the ubyte. And it just works. Hello world. Boom. So that's what we're gonna do first. We're actually, instead of that, before we even do that, so technically, yes, you can do this, it works, you can put it in a function, it will just work. Then we're gonna create another function that takes make ubyte and does the concurrency stuff that we're gonna do. Well, actually, no, we're gonna create the ubyte and then from there, work from there. Ubyte array, right? And this is gonna be the encrypt. A ubyte array, that's going to be going into the next step of it where we're going to convert them. How are we going to convert them exactly is questions. Very questions. We know that depending on how you cast, or how you would, well, technically, if you were to write these to a raw file, depending on how you write them out, they'll come out in different sizes. For example, if you put a fucking, what are they called? If you put a, what are these? A string that is cast to a uint, which is not the type for car, it will create 32 size. So when you write raw, that basically means that you're writing 32 and then 32 bits at a time instead of the usual car, which gives you a lot of space to work with. Technically, you can compress it. Also work on 2 numbers at a time. However, if you work on 2 numbers at a time, you then have to split them. So it's easier for us to create a algorithm that doesn't do that. So we're going to create a system. Shouldn't be that hard. So we're gonna create a ubyte. We're gonna call it our input. So the ubyte array input equals make ubyte, and then put a semicolon at the end. And that's how that's gonna work. So you're gonna make a ubyte and you're gonna create an input for that array. You're then gonna write the ln. And you're going to write input, since that's what we're working on, and I want to see what it looks like. And then we're going to go ahead and create another one by importing... actually, we might make another function that does it, but you would... also, when you import standard dot... I think we'll do standard dot task, or no, standard dot parallelism. Right, so import standard dot parallelism. We might just make a function that does this, And we want to import specifically the parallel, which is really just a easy way of doing it. Parallel. Well, no, we need to pass the string. Well, if we're calling a void, we can use standard parallelism to call these. I think we'll be able to do it with parallel. So you would then make a for each loop where you for each input, and then you have to track them somehow. Although we could compare them to the original input and then just rewrite them to a function like that. Anyway, that's one way of doing it. For each, and then you would do whatever you want to call them. Since they don't really have a for each car, for each CHR of IMPT, then we will create a concurrent thread, input. Yeah, for each CHR of input, don't put a comma there, put a semicolon. That's how you do that. And then you're gonna make, I have to read about parallel again. Standard dot parallel is standard dot parallel. What the fucking C? Every time I see C++, I want to vomit. Standard dot parallelism, D programming language. Nice. There's task, which is a struct. Where's all the fun stuff at? Oh, here we go. Parallel. Parallel for each R parallel range. Oh, here we go. For each parallel logs. Convenience functions that forwards to task pool that parallel. The purpose of these is to make parallel for each less verbose and more readable. So you do parallel. Oh. Oh. Log I plus 1. Wait. Logs? So like what? What is logs? Oh, you just be adding that? I'm confused. Sorry. But I haven't really used this in a while. Usually I use spawn, and then we reappend using spawn. Actually, that would not be a bad idea. Let's go. I like concurrency better. It's usually my favorite one to use. Which for that, you need spawn. You need this TID. Or you need spawn TID, something else, and another thing. Which basically allows you to send messages from a thread. Which, I mean, that's not necessarily what we need. We just need something that does a task and returns it. Let's go back, actually. Anyway, we're gonna parallel input then. Parallel. And then input. And you would have an I plus your input, I guess. So input then is gonna take... What? Parallel. Oh. Yeah, then you'd have your function, right? So what do we want to do? Create our... wonderful algorithm for this now. We want to create void algorithm. But we do need to return though, wouldn't we? No, we can't do it that way. But yes, we do need to create a function for that. And we do need it to return a value. What was the one I used in... let me check other programs to reference them. Open. Probably one of these has a lot of good examples of it. Because I did use it quite frequently here. Whoa, that's a lot of code. Which one is the one I want? Dictionary.d? No, go back. Oh wait, that was for the dictionary tooling. That would be... Anyway, what is this one? This one creates... Whoa, fucking don't take me into that. I don't want to see the binary. I don't want to see a raw object file. My eyes are bleeding now. Jesus Christ, all that raw binary in there, melting my fucking eyes. Anyway. I don't even remember what process was, honestly. Functional gaming, fish AI, v02, v0, host.d. Here's an example of my old sloppy code. By the way, you use _g shared for these, by the way. Don't do this bullshit. I like revisiting it, but I think you can use shared or g shared to actually make a global thing that's shared between threads, so please don't do what I did, because that's not how you're supposed to do that. Although it does work, it's a hack. And we don't like hacks. Anyway, return IM, a bunch of bullshit. What do I import though? Because that's all I need. Let me just copy all of that. And then import that into here. And then instead of doing all that, we're going to go ahead and do this. And then for each CHR, we're going to create a new one of these. So that void algorithm basically is going to be called in a for each loop like this. So for each input dot by UTF. Okay, keep going, because that's not the one. That's a function, void token encode. So inside of void main, it should call void token encode. For each word of words, spawn, point at token encode, word, count, and this TID. So let's go ahead and look at that. Token encode string. So that's what we'll do. So we'll spawn pointer token, no, not token encode, an algorithm. And then it needs to input those. So we look down here, we have word, count, and this TID. The reason we need those is because we do. Well, actually, we don't need word and count, but we do need to know what number it is. So for that, I'm going to put an I, and that's going to be inputted there. So this is that points at token encode, then it gives you word count and that. So those all go and get shoved in that function. So it does that function by pointing at it, and then does all the stuff. So it needs to put CHR I, and you technically don't need this TID. Actually, you do, because that's how you return a value, is you would send a message back. And then at the end, I think you have to clean them up. But I never did that in the original, so... Alright, so now we have that done. We take in our CHR. We'll take ubyte CHR. And then, bro, my encryption is better than it's ever been. Holy shit. And then we'll create an count, int count, and then we need to come up with a way to, that'll be later later problem, but we need to come up with a way to assign the values where each individual piece is getting placed. So that way it can be reversed on both ends. Alright, anyway. Int count and TID, this TID, which should be in somewhere in here. Did I import those? I should probably import that there. Because that's going to be imported inside of this as well. So spawn receive this TID, TID. Does it have that up here as this TID? No, it just has TID parent. So it only needs TID. I think it only sends. So it still needs that. It doesn't need receive. I mean, unless we want it to receive, like a termination or something. It doesn't. Does it need this TID? I think it does. It's a thread, right? So it should need this TID. Anyway, so this has spawn receive, this TID, TID, and send. We don't really want duplicates. Let's just go ahead and we don't really use receive in this one, so. But we'll not even need send in this one. You do need TID to have this TID. Although I don't think you need this TID in this one. So that's the imports done. If it's wrong, it will tell me, so who cares? Spawn receive this TID and doesn't need to send anything. This one has TID send. Cool. That's good. So that spawns points at algorithm, which then is this. And that's when we get to do our fun stuff to make things happen with the inputs. So we have our ubyte CHR, and we have our int count, and we have our TID. The count, that's basically, let's start with like the return value. Let's work from the bottom up, honestly. So here we have token and code. Let's see, scroll down. Where's the point where it does the return in that? Yes. You have to return as immutable. Oh. But that was because I was working with strings, right? I was working with strings. Ubyte output. Output does that. Output equals remove. And then some kind of weird bullshit right here. I don't know what the fuck this is. That's like a delta? I don't know what that does. Anyway, because I haven't really worked with those. Oh wait, that's a function without like an actual name, really. Return immutable results, worker ID, cast, and then output. Why? Why does it have to send that? Why does it have to send an immutable result? Where does it say that? That has return immutable. It can return the number and its number combined. Anyway, so what is output again? Output's an array, right? It's a ubyte array, yes. We're just returning a single ubyte. I think we'll be fine. But we still need a struct to handle this. So, we'll create a struct called output. Struct, and it's going to be called output. Then you do this. Boom, boom. It's going to contain a int for its value, which is count, int for count, and a return value, an int for the return, or a ubyte for the return. Return, and all that's going to get sent back and appended by a function in the main. Rturn. I like rturn, that sounds pretty cool. Rturn's cool. Alright, so then we're going to have it send that. So here it does a send. Send TID parent. So that's the first step, and then you would send it a result. Send parent, and then result, which is made at the end, which is just the result equal auto result equals. Now, when a word is purple, that means it's something the compiler does, by the way. It's a intrinsic, basically, which means the compiler just makes that happen. Pretty cool, right? So that means it will just take result from here and slap it right there. I am pretty sure that's how that works, but pretty sure it's just me not knowing exactly, so that doesn't count. Anyway, it needs to return an int, which is going to be the count, and probably CHR. Probably CHR. Very certain it's going to be CHR. So now it's time to do fun stuff to CHR. We'll take CHR, we'll multiply it. Actually, what are math things that you can do? Let's take CHR and reverse it. That's the first idea. Is invert CHR. CHR equals minus CHR. Wouldn't that set it to 0 though? Wouldn't you multiply it by -2? So like times -2. So that will be the first step. CHR times equals -2. And then we're just gonna spawn them. I need to create an appending function. So we're just gonna reverse what they actually are for now. But I want to return them. See, if I'm gonna do it like this, I'm gonna probably return them as a as an actual. No, we want to keep them as ubyte, but we want to invert them. I think times -2 is a way of doing that, because it should. Well, if we do times -1, that's sure to work. However, it's a ubyte. You need to cast to a byte to make it a negative. See, that doesn't work. God damn it. There is no such thing as, well, I mean, who knows? It might work. It might just be like, you can't do that. Now, there's a second portion to how this works in here, is when you have the return. So for that to work, you need to have this. Which I don't think you need to have this, honestly. Knowing what I know now, you could not do that and you'd get away with it. But anyway, you need to have a return that's dynamic. Alright, a dynamic array for the return. Don't do that. Okay, here we go. Here we go. Dynamic array for the return. So we'll do, what was the struct called? It was called output. We need an array of outputs. output array. We're just going to do it the simple way. Take the output array, we'll call it collector. I like that word, it sounds fun. Collector, he's gonna collect all of the arrays that we receive from the send result of these, and then he's gonna assign them. Now, we'll have a predefined thing up here, which will be the actual positioning for them, which will be just random based on a number. But for now, it'll be something. Who knows? For now, I'll just put... Honestly, we could just return them in a random order and it wouldn't be a problem. Well, we need to be predictable every time, so for now, we're going to just say each time it takes them, it's going to put them into their assigned position. So that's why we have count. So count's going to basically count the original position, or be the original position. It's going to be used inside of here. So ubyte array and we're going to do it based off of repeating values. We also need to figure that there's a potential that we could do it by increasing the length of the array, but I think we'll just go ahead and have 16 potential positions, and then ubyte array positioner equals, and then we have to declare all 16 of them now, starting with 0, 1, 3, 5. Make it easy. 1. Let's go in reverse order. So we'll start with 15, 12, and then skip a few numbers and go ahead and do 1. And then we'll do 10. As long as all the numbers get here, that's all that matters. And then we do 11. Now let's do 3. Let's do 2 actually. And then let's go ahead and reverse it again. And so I have that. I have 14, 13. Oh yes, counting really well. 3. Then I have 8, 7. Oh god, it gets longer and longer. What am I looking at though? I have 15, 14, 13, 12, 11, 10. I'm missing 9. I have 8, 7. Oh, next one is 4, 9, 6, and then lastly, the final portion of it, which will be what exactly? I have 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5 is missing. Oh yeah, all I need is 5 and 0. 5 and 0. So that will position the numbers. So for each of positioner, it will collect a number. Now, normally I would split it down into, you'd split it like by the space, or like you'd split it into an even number and then do it. But what I could do is just be like, yeah, assign it based off of this. So every time it's just gonna do a for loop and loop through. It's gonna be like 4, and then it's gonna position them. It's gonna create dynamic collectors based on that. But I could just do it with 16 tested off. Oh, I really hate this. But yeah, that will position them. by their values, or by their original value. And I guess we could just split it up and be like, yeah, we have 16. It will create a 16 array. So instead of doing this, where as a dynamic collector, yes, we have a dynamic collector, it's going to position them in their order. Positioner will just put them into a new order, create 4 different arrays, and then append the arrays. That's the better way of doing it. So we have our output, which is collector. It's going to collect and do its stuff. That's the first thing. Positioner comes later. So positioner is not going to get used right away, but the collector will. And the collector, we should focus on getting them into a collection, and then handling it, or into an array, and then handling it from there. That should be our first goal. I love hitting output, enter. All right, I have a plan. That's good. So yeah, we take that. We set the length. Can I do it in here where I do... No, you wouldn't do equals collector dot length, but you could do collector dot length equals input dot length, and then boom. That's the collection. Now that comes to the for each loop, which is this. For each I of count, for each I until count. Now count is up here. We don't need that, because we can just take input.length. Unless it gets uninitialized, but it's still initialized the entire time. So once it gets down to here, let's see. Boom. For each of those, then it's still initialized in this. In this scope. It should still be initialized because it's at a higher level in the scope hierarchy. Would be a way of saying that. I'm not sure if hierarchy is the exact terminology, but clearly it follows from here into this scope, and this won't exit this scope because it's scope guarded. So that means it should technically work to use input.length instead of count, so I don't have to initialize count as a variable that's global or something like that. I don't want to do that. Or do fancy fucking confusing scope guards like I did there. No need for any of that. Positioner will go in its own scope guard. It's going to just exist in a separate realm from all of this, probably. Actually, no, it does need to exist with the collector. No, it won't. Because you could just set input equals the collector, and then split it, and reassign it, split it into the length, and then reassign them based on that. But no, you don't want that. Hold on. Let me think for a second. How would you split it? How would you do... Or, no, let's focus on collection still. Before we focus on this at all. Because obviously, yes, we're going to take it and break it down into 4 or however many arrays of these numbers, and then position it by those. Which is the scramble step, as prescribed in the original versions of what we're making. So receive immutable, or return immutable results. I remember trying so much shit to do this. Anyway, for each, and then you would do I semicolon input, because yes, it's for each member of input. Technically you could do member for each car of input, no, for each CHR of input. And instead of doing all that dumb shit we did in there, we're just gonna receive it based off of the amount of CHRs there are. Because we don't need to use CHR. Nobody says you need to use CHR. You could just use it to create a until loop, kind of. Do this until we reach the length of count. And you could do that by just doing this. and using your original array, sorry, not variable, that's way more effective. Now, then this step, we have order, which is result.worker ID. Oh, that's the original collector. And then it equals that. Instead, we're just going to put a I. And you don't need to be doing that, I guess. So for each I of input, then we're just going to do the I. We'll do it here. Receive the return result. Receive. Do we have receive in here? Yes, we do. All right, cool. So receive the result, which is not that. It's the output. Duh. Output. And CHR is the return, and yes. Receive and output. Receive, what is it even though? Does it receive the, yeah, it does. It just receives, oh, it receives a type. So you declare what the type of the output is first. So you would do receive, and then you would do like, output, and call it result, or, yeah, result, I guess, is what I called it originally. So yeah, here, auto result equals output. So you receive that, and then you would go ahead and make this, and create a scope for it. And after that scope, you put a semicolon. That's the valid formatting. And then that then does order, and it creates and it casts that. But you don't need to cast if you're not working with immutable stuff. So order equals result. Now, here's the thing, though. When you create a struct, it's only really going to be initialized in one of these. So that's a potentially bad thing, but we will need... That's part of why it doesn't work originally, was that it didn't want to send it back. So, anyway... Because it can't send back a struct unless it has something to maybe place it in? I don't know the words. But anyway, order equals result. No, you would do collector of I equals result. And then from there, you could do a for each loop, which takes the result of collector and puts it onto our positioner. So now I think it's ready to test, and once it's done, we'll go ahead and create my write-ln function for write-ln result. Hopefully it's ready to compile. I think that'll be the first troubleshooting thing, is we have to compile write-ln and then do collector. Thank you, finally. Fucking collector. Alright, so let's do it. First thing, it finds unidentified identifier, TID. We might need to do those globally. Import them global. Yes. Wonderful. Wait, before we get to that one, let's just do this at the top, just to make it simpler. Since it's going to be imported globally, it's got to be done at the top. So import TID and send, which no longer means no longer do I need to put TID down here. So boom, done. That simplifies everything a little bit. So yes, definitely compiler troubleshooting right now. Compile issues. Alright, here we go. First, error struct output is not callable using types, int and u bytes. Auto result equals count. And these are exclamation point parameters, int, comma, u byte. Excuse me. So what is count again? Oh wait, did I do it correctly? So we take CHR, we take our I. Did I put them in reverse order? I definitely did. First mistake. Boom. So that's the first one. The next one, go down. 3, candidate is output. Struct output, candidate is output. Where is that at? Oh, never mind. Just keep going. Template spawn is not callable using argument types. Void function. Did I put a pointer? Yes, we have a pointer algorithm. Does it run as a void function inside of this? Yeah, it is. Okay. So then, let's see. Void function, and then it should be just a pointer to the function. CHR, this TID, and then that. I mean, that should be doable. I'll look for more compile time errors, because those are the ones I'm worried about. I'm surprised unidentified identifier, receive 33. Receive? What do you mean receive is unidentified? Is it not in the scope? Does it need to be in that specific scope? Unidentified identifier, receive. What do you mean? I call receive in here and it worked. Maybe I didn't misspell it. It's just receive. Receive, return, immutable result. Oh. So cool. Maybe it's the output and the result afterwards. Maybe it's the... Oh, wait. It could... You know what it could be? Unidentified identifier, receive. Somewhere up here, we must have fucked up something. Anyway, let's just try 30. Encrypt is use type within the template struct. Output is used as a type without instantiation. Output array collector equal. Here we do return array order, which you don't need to do any of those, right? You need to want return. Yeah, you don't need to instantiate. Shut up. Slap it. Alright, now it's got more errors. Output is not callable using function types. Count, int, or count CHR. Candidate is output. What do you mean I can't declare it as those? Right, up here? Oh, right, do I need to put int in CHR? Oh, you know what it is that I put it in wrong order. I now put this in the wrong order, right? It's, oh, yeah. Yeah, now they're in the wrong order. That's why you do things by a one standard order. So if you do ubyte first, you always will do ubyte first. Stan Dard is my best friend, and he tells me these things. Do them correctly, and he will laugh at you for when you screw up. Alright, so yeah, output's the problem. Doesn't want to make an output with count and CHR. What? What do you mean you can't make an output with int and CHR? Go up to here, it's got this in that, and it has that in that. Using, is it because I did int seconds? Return count and CHR in the opposite order. Yes. Error struct output is not callable using the types. Maybe it's because they're like a pointer or something. Anyway, scroll down. Callable using types. Spawn is not callable using types. Template spawn. Template spawn. Okay. And I think it's probably just this. Maybe something's wrong with this, apparently. How do I set up the actual declaration of the void function in here? Yes, it takes string, and it does that. Bro, saying that concurrency is the most jankest of all. Pointer algorithm. Am I still pointing at the algorithm that we have? So void algorithm, maybe it could be the thing that's wrong with it, but it has void. That's correct. Yeah. That's correct. Yeah. So good. I think the only possible problem is the send result problems. Honestly, this is... Candidate is F. Does it want an actual function? Excuse me, do you want an actual function, not a function pointer? Or wait, how is it declared down here? It's a pointer to the function, right? Creates a pointer to token encode. So, wouldn't that be the correct way to do it? Pointer to token encode. Callable using type, or without, or, oh. Using types. What if I just spawn the function without doing a pointer? So like backspace hacktivism right here. This is truly the greatest hacktivism of all time. Oh yes. Boom. And that algorithm is not callable by types. You byte this TID. What do you mean? Interesting. Not callable by types, you byte. What? Hold on, I gotta piss. I'll be back. Oh, and I's a U long, that's fun. So I is a U byte. I is a U byte. Or no, U long. So we need to handle that as a U long now. Didn't even realize it's a U long. Ultra long. Unsigned long. Okay, cool. Solved that one. That one's now been solvified. So let's go ahead and swap to a pointer again. Undo all this shit and swap it back to how it was. Backspace, comma, backspace. Alright, that's how that works. So if you pass the I over to it, then it has to be done the other way. So receive unidentified identifier, receive. It's declared up here. Oh, I wrote it with a backwards fucking I. Oh, me being bad at English has failed me today. Alright, do it again. What's next? Use the type without instantiation. I don't see why it's complaining about this problem. See, we have output array, which shouldn't need that. We already have done this before. You can do this. It's a thing you can do. Template struct encryption mk4 that output is used as a type without or instantiation. To instantiate it, use output exclamation point. Forgot what these are, but I know they're a thing. And then arguments. I don't need to do that. It's an array. What do you mean it needs that? Oh wait, but that's in D33. That is the output array, right? Output result equals output, maybe? Equals output array. Here we just have return array named order. So return array order should work, in theory, for the same code. What is return even? It's right here. Return. Has a U-byte array and just works. So then output array collector should, in theory, also work. Use as a type without instantiation. Did I do something? Am I confused? I think I am. Because you have this here, which is capital return, which is the same as this. Maybe it's because of how... Caught it. Good. My eyes have yet to deceive me again. Finally, we just have to do this. Cannot implicitly convert count to int. Where's that at? ulong. That's done. Now I have encryption Mark IV. Cool, let's test it out. Let's see what it does. That was like stupid mistakes. Hello world. Alright, let's see. Something with concurrency. I can't read all of this. This is too much for me to read, so... Index 104 is out of bounds. Oh. I know what it's doing now. Oops. You know what it's doing? So instead of, it's taking the actual value, turning it into a... Wait. Are we applying this correctly? That happens at the apply portion where we're applying them for an array length of 12. Index 104. So the 104 comes from this. I'm guessing the first letter of hello world is a 104. So slapticate that and then just put a CHR in there. Pretty sure that will work. Now back to DMD encrypt.d /encrypt.d hello world. And we now have our outputs with their positions. However, the positions should be correct. No, they have values, so of course. Nice. Technically, we could do as... Okay, so for positioner, that's the fun part. Positioner, we have to decide on how they're going to be positioned and come up with a method of... or technique to apply that will put them in a order that's predictable for reversing. and I want to cast that to a string, I think. So they come back in a wrong order, which is terrible. We want them in a correct order. To do that, in here, when we receive them, we receive it, and we use the result.worker ID. So instead of using collector of I for the index, in fact, we don't even need to do any of these. You don't even need to have a CHR in there. You don't even need to... Oh. Oh, wow. You can use an I. It'll be fine. It'll act as a CHR. But instead of doing all that CHR stuff, we just... now we just grab the stuff and put it into... what is it called? There's words. There's words somewhere. They're just not in my brain at this moment. Maybe tomorrow they'll be there, but who knows. So yeah, you just collect them, and then you assign them based on their result dot count. So that will return the values correctly. Just making sure that's correct. So then, boom. And instead of doing a struct array, let's create a ubyte array called collector instead. Ubyte array collector. Sorry, C# is stuck in my brain. I don't even use it often. So collector, and then we're going to assign the result dot... What is the other one? Rturn. And then boom. That's the even better way, the even juicier way. Even juicier. Look at that. And it brings them back and did a weird thing to them. So just to verify what this is actually doing, what we should see is that it is inverting the letters, or the values of these letters, or whatever this is. I have no idea. So what we're gonna do now is we're gonna add in a write-ln to give us a formatted output that returns the output value now, since we actually have a working system for returning them in order. And instead of using a positioner system, because that's not going to be dynamic, we can shift them and other stuff. So cast, and then you could cast it to a string right away. I hope that works. I'd be impressed if this works. Hello, world. A bunch of question marks have been returned. Well, obviously, that's fun. Thank you for question mark. China. Anyway, we want to not do that as vigorously. Let's go ahead and... But you can work on a byte-wise operation, or a bit-wise too. You could be like, alright, let's go ahead and do a bitwise OR with the number 7, and then see what happens then. Oh, you would do equals pipe, and you do CHR, and then do that, just to make it look good. Ooga wooga. Oh yeah! We now have a value that is crazy. Ooga wooga, what the fuck is this shit? Bitwise. I've truly elevated my game from 3 months ago, obviously. Now, what other fun shit can I do? Well, if I do CHR equals... And hell, before we even get into that, we could shift it inside of like this function. So before we get there, That'd be the first step, is we shift it. Shift the entire string, the entirety of all... Well, let's do that at the end. That's an end step. So for now, let's focus on individual numbers. And then let's do CHR equals CHR minus 6 equals minus equals 6. Hello world, which gave us Ayai Koyeki. Fucking shit. Trying to pronounce these is hilarious. But what if we did like an OR? Can I do like an OR? That's for like comparing. But can I do that? Does that work as well? Oh? That does something. It can do either 6 or 9. Actually, that just pipes it. Whoa. You know, we should revisit the AI project. Equals cosine. No, don't even bother with stuff like that. Cosine is crazy. Let's do I, and then let's put in. Oh, we could use the count. Use count, and then shift it by count. Minus equals CHR shifted by count to the left. I hope it doesn't break. Ogwog. I don't know. It sounds like Ogwog. See, it's got a G in there. G question mark, question mark. Of course, you have to be able to redo these. Well, that's why the algorithm comes into play. And then we could use pipe and OR for car for CHR. So that way it depends on if CHR or that are true, which would be pretty much guaranteed. Whoa, it just turned a bunch of them to fucking zeros. You can't work with zeros. It has to be greater than 0. So the outcome can't be 0. It's null if it's 0. That's pretty much useless to us if it's 0. But we could still do count, and we could do count and then add or subtract 3 underscore 3? No, minus 3. And then, trying to think of other ones. We could do CHR equals CHR pipe, and then do like 3 times, or shift it, and then multiply, or yeah, shift it right by, don't do any shifting, it's bad. Because that will make a mask. You don't want to shift these. You can only shift after these. So yeah, that's why it doesn't work well. This, and then count, and then 4. Yeah, that number. Odd numbers are more fun because it makes it math harder. Ah! Fuck. Can't convert it to a... Okay. Now, if one of these returns 0, that's another thing. You can't have one of these return 0. Let's replace this with a 3. Let's do minus. Let's do plus. I want to try to avoid bitwise, because it will potentially... Oh, these need to be cast. No, actually, these can just be U-byte. I think that works. Cast to an int? What do you mean cast to an... I guess it casts it to an int to do this? Fuck. Or, injecting numbers. I mean, I guess or 7 just puts a 7 in there. Like, it made a bunch of them to, like... Let's see what it did before. Because when we did it before, it did a bunch of weird shit. Rip on. Rip on! Oh, wow. Funny. 14. 105. 112. 111. 110. Wait. Oh, okay. That makes sense. I see why it's rip on and not the same as this, where the 1.8 is... See, there's a difference because the value of them is different. So when it returns that value in the same order, it creates that. So it will be like in the same order, but this one is 111 and this one's 102 because it factors in the count. So 1, and I want to see no zeros. If there's a 0, it's fucked. So it just turned the space into a percentage. Awesome. I think that's about all I can do in that, because I don't think you can go further than a certain amount with this. Although we could do CHR plus equals CHR minus CHR or and 6. I think that works. See what this does. There we go. Look at that. 120, 111, 118. Are these in the same order though? 117. It looks like they are. 116. As long as we can return it back. So the next step is to return it back. So if you have hello world, you want to take this string and then return that back to how it was using the same thing. Let's see. You just do it in the reverse order, honestly. Anyway, to put it in a different order, let's focus on that now. So you'd cast to a string, and then what you do next is simple. So we cast collector to string to a string. No, we cast string to collector. Whatever you're talking about. Fucking brain cells. I knew something wasn't right. Collector. And then I don't think you can do bitwise on collector. You would need to like append all of the values together. Unless you take the indexes and then shift them, or like do some adjustment to them. So you would do like what? Also, it looks like every value got increased by 3? Could you just take the whole thing and then... Or we could do a for each loop. Right, so for each, we're going to say I and collector. Now what we're going to do, we're going to put each I, and we're going to shift the position. We're going to... No, I mean, I guess you could take the index and be like, yes, as long as it's between... I think we'll hold this off for tomorrow. I think I've done enough working at this problem, so we'll do that tomorrow. We'll just work on this all week, and then once we get to the weekend, we'll see what we're doing. I'd like to thank you all for watching. I'll see you all next time, and goodbye. This is where I'm going to end today's episode. So we did a lot of stuff, and we really advanced a lot of the technology I was using before, so goodbye.